Hello everybody, my name is Ionescu and today I'm going to talk about an agent-based model created to evaluate interventions that decrease racial homogamy on online dating platforms. This work was done together with Hannak and Kenneth Joseph. Perhaps one of the most controversial questions in social media research today is to what extent can platforms intervene to reduce societal ills? And as you already know from the title, in this talk I'm going to discuss online dating and its potential to decrease assortative mating patterns. But maybe this is not your favorite application, and in this case, there are still some useful takeaways from this work that can be applied to other domains. Because the higher level of our goal of our paper is to show that agent-based models can be successfully used to integrate our knowledge about society in order to test different interventions. And maybe some details such as the different parameters that we use or the different phases that are involved in online dating will not be transferable, but more general things such as the preferences of agents, their stereotypes, the social norms, and how all those interact with each other are useful takeaways that can be applied to other domains as well. And talking about other domains, what I have in mind here are other matching markets such as school choice, which also show assortative behavior that leads to segregation, or you can also think about discrimination in two-sided matching markets such as ride-sharing platforms or the labor market. But going back to our application domain, the question that we ask here is to what extent can online dating platforms reduce racial homogamy through interventions? And if we look at the recent literature, we have different views. For example, on the one hand, we have the Hudson et al. CSCW award-winning paper from 2018, but we also have the 2018 Anderson et al. Paper published at Sociological Science. And Hudson et al. Claimed that looking and considering platform design can show us the opportunity to decrease racial homogamy, and we can do this without reducing the decisional autonomy of the users. But on the other hand, Anderson et al. Say that just alternating the structural environment will not necessarily decrease racial homogamy. And the reason for this is that, according to their findings, racial homogamy is in part the result of same-race preferences. Before going forward and discussing the model and the results, I want to talk a bit about the relationship between racial homogamy and societal ill. First of all, we use here racial homogamy to mean the tendency of individuals to seek out and engage in long-term relationships with others who are the same race. And there are 2 points that we want to make here. First of all, we don't think that racial homogamy is in and of itself a societal ill, because you can think of many legitimate reasons while others might want to have same-race partners, especially if we think of those identifying with an oppressed social group. But on the other hand, you cannot say that it does not contribute to the reinforcement of racial inequality through segregation and income inequality. And those are exactly the reasons why Hudson et al. Suggest interventions that platforms can take and say that racial homogamy is worth of platform intervention. But even if you agree or not, there are still some useful takeaways, because what we do is analyze what will happen if those suggested interventions were implemented, both in terms of racial homogamy and in terms of user satisfaction, and on which assumptions about society do those results depend on. Now we are going to talk about agent-based modeling. And when I say agent-based modeling, what we do is create artificial agents that mimic the behavior of real people. So they have their own attributes, their preferences, they interact with each other, and so on. The reason why we use agent-based model is that it enables us to ask what-if questions. So to see what will happen in case different interventions were implemented, and what will happen if the society would look differently, and so on. And we can do this in a faster and less expensive way than with a purely theoretical approach, than with an empirical approach. Because if you think about having a separate, creating a separate platform with all different interventions and testing it on different populations, this might first of all be unethical, and secondly, it will be time consuming and expensive. It also enables us to explore more complex causal implications and to think that might be difficult to think through with a purely theoretical approach. When going to our platform, an agent can first create a profile. So looking at their own attributes, they will say maybe if they are passionate about music or not, or their self-identified race. They can also choose not to specify one of those attributes or maybe even all of them. They can also say what they're interested in seeing in another person. For instance, they can say that they want to see people that are interested in music because they are. Based on this reported preference, the platform will give a list of profiles to other agents. For instance, they might give them a list of other profiles, in this case, that of people that are interested in music. If our agent sees somebody who they want to talk more to, then what they will do is send them a message. And this means that every agent also has an inbox with all the messages they received so far. If they reply to one of those messages, then the agents will start an online relationship, so they will start communicating a bit more. The agents are represented in an easy way, so they have, first of all, attributes. In this case, our agent has a self-identified race of 1, and also another attribute, let's say the interest in music. They also have a preference, and the preference specifies how much they care about each attribute. This preference is not that biased because the agent cares more about the second attribute than the first one. And they almost don't care actually about the first one. Personal stereotypes are similar to what you would expect from real world. So they show how likely somebody thinks that that different attribute combinations are to be encountered in practice. For instance, here, our agent thinks that they are more likely to meet other people who have equal values of attributes on the two components. The simulation progresses in iterations, and in each iteration, the agent has a turn, and during their turn, they can do a limited number of things, depending on the phase they're in. They start within a search phase, so this means that after completing their profile, they will say, based on their preferences, what they want to see, and based on this, they will see a search result, and they will think whether or not they should message somebody or reply to one of the messages they had so far. If one round of messaging was successfully exchanged, then the two agents progress to an online relationship, which means that they will interact online, and based on that interaction and its quality, they will think of whether they should continue the relationship or not. They might also learn new attributes about the other person. In this case, our agent learns the self-identified race of the other. They might also update their own preferences and stereotypes. If an online relationship progresses long enough, then the two agents might progress and go to meet face-to-face, so go to an offline relationship. And this is similar, but the agents can learn even more attributes about the other person. Again, if an offline relationship matures enough, then the two agents will happily enter a long-term relationship and they will exit the platform. There are other less happy ways that somebody can exit the platform. For instance, if they have too many unsuccessful search terms, so they see consistently bad search results, for example, and they don't see interesting messages, or if they had too many failed relationships. I also mentioned norms, which are socio-cultural regulations on one preference. And to see how those play a role in our model, I will give an example. Let us assume we have this scenario when we have two agents. One is our agent from before. They don't have much bias in their preference. And the other one is another agent who maybe thinks the two attributes are equally important. There is also a norm, and the norm says that people are expected to care more about race when deciding on a partner. In this case, the norm will influence the preferences to go a bit closer to the norm at the end of each iteration. So what will happen is that we take a complex combination between each preference and the norm, and in this case, it will add some level of bias to the two preferences. Here, I exaggerated the weight of the norm, so what will happen in the iterations is that the norm just changes the preferences a little bit in each step, but I've done this just to show the direction of the change and to emphasize it. If we are talking about the on-platform norm, the agents are the one forming the platform, so they also have a say on the norm. In this case, the preferences of the agents also influence the norm, so the norm at the end of the iteration will become a bit closer to the average of the preferences. In this case, the norm will become less biased. Now that we've discussed a bit about the environment and about norms and filtering and so on, I'm going to talk about the platform intervention suggested by Hudson et al. And how we included this in our model. First of all, here in the talk, we are going to only discuss about two, but there are a bit more in the paper, in our paper. And there is one more in the Hudson et al. Paper that we didn't implement, and this is the matching algorithm intervention. And we didn't implement this one for two reasons. First of all, not all platforms have a matching algorithm. And secondly, even the ones that do have one do not discuss it that much, so we don't know exactly what it is, and it also differs from one platform to another. So this will require more discussion to be properly analyzed, this type of intervention. But the ones that we're going to discuss today, the first one would be a filtering intervention. So when people are searching, they can say what their preference is. For our agent below, for instance, they care more about race. And based on this, they will see some results. Without any interventions, which we'll refer to as a strong filtering option, the agents will see profiles of others who have the same race, a 1 on the first position, and anything else on the other position. So any other attribute. We can also add a non-race option on top of the existing filtering option. And what will mean in this case is that the agents are not allowed anymore to filter by race, and instead they will look at the second most important attribute according to their preferences. In this case, because we only have two attributes in this example, this would be the second attribute. So in this case, our agent, if we have a strong non-race filtering option in place, they will only see profiles of others who have declared as 0 on the second position in their profiles and anything else on the first position. An alternative is to go from a strong filtering option to a weak filtering option. And in this case, the agents are still allowed to filter by race, but they will see more diverse profiles, because they will also see the ones that have an unspecified value of race, so not specified value of the first attribute, and anything else on the second attribute. You can also put a non-race option on top of a weak filtering option, which will do the same thing, but on the second attribute. And of course, an alternative is not to filter at all. So people are not allowed to filter, so they see a random permutation of the profiles that are on the platform. Another type of intervention is the on-platform norm intervention. Without any type of intervention, so if this one is off, the norm on the platform can take any value, because at the end of the iteration, it gets closer to the average of the preferences. But we can also keep the norm, we can also intervene on the norm, which means that the platform encourages its user not to care about race when choosing a partner. And in this case, the level of bias in that norm will remain at a value of 0, so the first attribute will have a constant value of 0 throughout the simulation. Now I'm going to talk about results, so the interesting part. On the x-axis, you can see in our plot the filtering intervention. You can also see the different norms interventions. Either it can be off with a triangle or on with an X. And on the y-axis, you can see the percentage of outgroup long-term relationships. Outgroup again means that the relationship matured enough and the two people spend enough. Outgroup meaning again that the two agents involved in the relationship are of different race, and long-term meaning that the relationship matured enough through the online and the offline stages, so the two people exchanges enough messages online and spend enough time meeting face-to-face such that their relationship progressed to a long-term relationship. You can see here, and we use this as a measure of racial heterogamy, which is the opposite of racial homogamy. So higher percentages here will correspond to lower levels of racial homogamy. You can see here that most interventions have a positive impact on racial heterogamy. For instance, going from a strong to a weak filtering option, going from adding a non-race on top of this also produces the same outcome, and all the same happens with norm interventions. However, the percentage is, of course, composed of a numerator and a denominator, and these results are not solely due to the increase in the number of outgroup long-term relationships, but also because of a decrease in the overall number of long-term relationships in some cases. I'm also going to talk now about user satisfaction. And as a measure here, as you can see on the y-axis, we use the percentage of time spent offline, so the percentage of time people spend in face-to-face interactions. And the reason why this is a measure of user satisfaction is that users don't usually like to spend a lot of time searching and communicating online for little to no offline interaction. So higher percentages here correspond to higher levels of user satisfaction. What you can see is that usually interventions that produce the higher increase in racial heterogamy also produce the higher decrease in user satisfaction. We also looked at a different metric for user satisfaction, which was the percentage of exits of users because of not being satisfied with the search results. So because the platform didn't do a good job giving search results, and the results there are similar. I also want to point out that those results that we presented in the past slides also depend on the specific assumptions about society. For instance, if we assume that the level of bias in the out platform norm increases, then we will see lower increases in racial heterogamy and also more dissatisfied users if the changes were implemented. Another example is the level of correlations between race and the other attributes. With higher levels of correlations, we'll again see the same behavior. Last, I'm going to give an overview on the contributions of this work. First of all, the first 2 points that I will make here are specific to online dating. So first of all, we saw that various interventions do indeed decrease racial homogamy, but they do not achieve a fully mixed outcome, so we didn't achieve a 50%. And this suggests that we might want to look beyond the suggested interventions if we want to achieve such an outcome. Besides, the benefits depend on specific assumptions about society, such as the level of correlation between the race and the other attributes, and also by the level of bias in the out-platform norms. Moreover, often those benefits are at odds with user satisfaction, so which is important because if interventions will make users dissatisfied, then platforms might be less likely to implement those interventions. The last point is a more general one, and at a more general level, our paper aims to show that agent-based models can be successfully successfully used to incorporate our knowledge about society and test the effects of different changes and different interventions. And we hope that this work can be used as a blueprint for other applications as well. Thank you very much for your attention, and we look forward to discuss this further into the Q&A session.